chunks he called quantum. And what he meant by that is there is a certain amount of energy. Energy is given out in chunks, okay? So these chunks, oops, it'd help if I spelled chunks correctly. These chunks are a certain amount of energy, specified amount. And if you're going to go up or down in energy, you can only go by one chunk, okay? Now, the reason we have the stairs here is because if this guy is walking up the stairs, right, he can go from this stair to this stair, or he can skip a step, right, and he can go from this stair to this stair, but he can't go, like, only halfway up the stair. It's not possible. There's no place for him to put his foot, okay? So the quantum for the steps is 1 step worth, okay? He can go up these stairs in 1 step intervals, okay? So he could do 1 step times 2, right? Or he could do 1 step times 3 if he's really good, but he can't go 1 step times 3.5. It just isn't going to happen. There's no place for him to put his foot, okay? Same thing with energy. These quantums come in whole numbers in, well, I don't want to say whole numbers, in specified chunks, okay? All right, so then Einstein added to Planck's theory, and he decided to name these chunks of energy photons, okay? And here's that picture again of the radiant energy hitting the metal and electrons being emitted, okay? And over here in this one then, we've got the radiant energy that's coming down, and it's bumping off these photons, which hits off electrons, okay? And it runs to this terminal, and what they're showing you is that you can actually get a current. So this radiant energy bumping these electrons off is enough to close the circuit so that you get current running through here, okay? And again, this is not a V, this is the Greek letter nu. Here, H is Planck's constant. Planck came up with what that multiple is of the energy, and it is 6.26 times 10 to the negative 34 joule seconds, okay? All right, and then from there, matter also behaves like waves. And here's the equation for that. Here's the tricky part. This time, this actually is a V. V for velocity, okay? I know, they're trying to confuse us. But we still have lambda for wavelength and h for Planck's constant. And then this m is actually for mass, okay? And this is for velocity. So we can calculate for any object, any piece of matter, okay? We can calculate its wavelength. All right, and then because matter behaves like both waves and particles, we have this thing called Heisenberg's uncertainty principle, and he says that we can never know exactly, we can never exactly pinpoint where an electron is going to be, okay? That's why it's the uncertainty principle, because we are not exactly certain of where it is, all right? And he has this crazy equation, okay? So you've got your change in x, that's the position, multiply the change in this they call momentum. It's mass, the mass